Let's complicate the inequality a bit. Let's take a look at -6 times the quantity x minus 3 is greater than or equal to 2 minus 2 times the quantity x minus 8. So again, we are going to treat it like it said equals, unless we come to a step where we are multiplying by a negative or dividing by a negative, in which case the inequality sign flips. So with parentheses, what do we do first? Well, in an equation, we distribute to clear the parentheses. And that is what we do here. We're going to distribute the -6. Over here, we'll distribute the -2. -6 times x is -6x. -6 times -3, positive 18. On the other side, distributing the -2, bringing down the +2, and this will be greater than or equal to. There's no risk of us doing anything here. You might be saying, wait a minute, you're dividing this side by a negative, or sorry, multiplying this side by negative, and you're multiplying this side by a negative. Isn't that the special rule? No. These negatives already exist here. In the other problems, it's the steps of undoing everything. If we're multiplying by a negative in the problem, we will divide to get rid of it. But here, we're not getting rid of the -6. We're getting rid of the parentheses. And we're not actually multiplying the same thing on both sides. So this isn't what we mean by multiplying both sides by a negative number. Bring down our 2. -2 times x is -2x. -2 times -8 is positive 16. Yes, I will show an example of what we do mean by multiplying by a negative number after this one, because we've been doing dividing. So I will show one that clears up what multiplying both sides by a negative would look like. In the meantime, let's finish this one. Simplify by combining like terms on both sides. Nothing to combine on the left. On the right, +2 plus 16 is positive 18 minus 2x. I'm going to go ahead and add the 2x to both sides. -6x plus 2x is -4x plus 18. If I subtract 18 from both sides, I get -4x is greater than or equal to 0. And let me write this over here. From -4x greater than or equal to 0, if I divide both sides by -4, I get x is less than or equal to 0. Got to flip that sign because we divided both sides by -4 in the process of solving. On a number line, if this is 0, less than or equal to 0 would look like that with a square bracket, which means our answer would be -infinity to 0 with a square bracket on the 0. So just real quick to knock out that one I promised you before we do another one just like this. Something where we'll end up multiplying both sides by a negative number could look like this. T over -3 is less than 1. Here we would need to undo dividing by -3. We would do that by multiplying by -3. And here we're multiplying both sides by -3 to undo division. And that switches the sign. 1 times -3 is -3. Hopefully by now we're getting used to putting our answers in interval notation and getting that interval notation from graphing. Let's do another one with all the parentheses. 5 times 3x plus 1 is less than 4 times 5x minus 5. Distribute. 15x plus 5 is less than 20x minus 20. Going to subtract 20x from both sides. That leaves me with -5x plus 5 is less than -20. I'm going to subtract 5 from both sides. -5x is less than -25. And from there, which I'll move up here, I'm going to divide both sides by -5. Leaves me with x is greater than, because that flips the sign. Negative divided by negative is positive. 25 divided by 5 is 5. Five to infinity inside parentheses. Okay, let's throw in some work with fractions here. X plus 1 over 3 minus 2x minus 4 over 6 is less than or equal to -x over 2. Now, here, we can go ahead and multiply both sides by the least common denominator. And in this case, that's going to be 6. So if we look at our multiple list for 2, 3, and 6, six is the first number that shows up in all 3 of the lists. That means that 6 is the least common denominator of 2, 3, and 6 fractions with those numbers in the bottom. Why am I doing this? I'm doing this because it's going to get rid of the fractions. So notice multiplying both sides means that the 6 gets distributed to both of these terms. So it's like having a 6 times the x plus 1, and all of that's over 3. It's like having a 6 times the 2x minus 4. All of that's over 6. And here, it's like having a negative 6x over 2 instead of just an x over 2. The 6 gets multiplied by that fraction. How is this helpful? Like I said, it's going to get rid of the fractions for us because 6 over 3, that's just 2. And then 6 over 6, that cancels. So that's minus the entire 2x minus 4. Very important to keep that in parentheses because it is subtracting that entire thing, which means in the next step, we're going to have to be sure to distribute that negative. Less than or equal to negative 6 over 2. That's negative 3x. And look at that. The fractions are gone. If I keep simplifying, I'll get rid of the parentheses next. 2x plus 2. Distribute to get that negative through there. Negative 2x plus 4. The opposite of the negative is positive. Less than or equal to negative 3x. If I combine like terms on the left, 2x minus 2x, those cancel each other out. 2 plus 4 is 6. Less than or equal to negative 3x. When we finish this up, 6 less than or equal to negative 3x, we see we're going to have to divide both sides by negative 3, which is going to flip the sign from a less than or equal to a greater than or equal to. 6 divided by negative 3 is negative 2. We're just left with the x there. Be super careful. This one ended up with our x on the right. This would be the same as x is less than or equal to negative 2. So right now, don't ask, why did it flip back? It didn't flip back. Here, we switched it, but the left side stayed the left side and the right side stayed the right side. Here, we're switching the whole thing. The left side comes from the right side. The right side comes from the left side. And then the little point stays with the x. The little point stays with the x. Pac-Man's mouth opens towards the negative 2. So on a number line, this would actually be to the left. Negative infinity to negative 2 with a square bracket. Let's go ahead and do another like this one. M minus 4 over 2 minus 3m plus 4 over 10 is greater than negative 3m over 5. The LCD, the least common multiple of 2, 5, and 10, that's going to be 10. I'm going to go ahead and multiply both sides by 10 so that I can get rid of the fraction. So this would be 10 times m minus 4 all over 2 minus 10 times 3m plus 4 over 10 is greater than, this is going to be negative 3 times 10, negative 30m over 5. The 10s cancel there. Here, 10 over 2 is 5 of these m minus 4s. And we're subtracting, in parentheses, the entire 3m plus 4. And then negative 30 divided by 5 is negative 6m. Distribute. 5m minus 20 minus 3m minus 4 greater than negative 6m. I'm going to go ahead and erase the top of this problem to give myself more room to work for now. I'm going to recopy this line exactly with no changes. 5m minus 20 minus 3m minus 4. This is, again, just so I have the room. You don't need to write this a second time. You can obviously just keep going. It's minus 3m. 5m minus 3m would be 2m. Negative 20 minus 4 would be negative 24. Less than minus 6m. I'm going to do this two ways. So there goes the rest of the middle. Because I'm going to do this two different ways to show you that there is a way where we don't flip here. So two different ways. You don't have to do both, but I'm going to show we get the same answer either way. So I'm rewriting this line two ways. First, I'm going to do it like we did the last problem. Since I can get this all done in one step by subtracting the m's to the right, I'll go ahead and do that. If I subtract 2m from both sides, negative 24 would be greater than negative 8m. And then I would divide both sides by negative 8. Negative divided by negative is positive 3. But since I did divide both sides by a negative, the inequality sign gets flipped from a greater than to a less than. We get 3 is less than m. To help me graph it properly, I'll switch the whole thing around so that the m goes over here and the 3 goes over there. And then the big side stays with the m and the little point stays with the 3. So this would be m is greater than 3. No or equal to 3 to infinity would be the answer. What if I always, no matter what, wanted to do every problem by taking the variables to the left and the constants to the right? In other words, what if I did do plus 6m as the step here? That'd be okay. There's nothing wrong with that. Be careful though, because now everything is on the left. 8m minus 24 is greater than what? 6m minus, or negative 6m plus 6m, those cancel away completely. 0m on the right. Leaving the m's on the left, I would then go ahead and add 24 to both sides. And then look at that. 8m is greater than 24. No multiplying or dividing by a negative going on here. Just dividing by 8. M is greater than negative 3. Will you look at that? Same answer. So same graph, same interval notation. So either way, we get M is greater than 3 here. If you need a break, take a break. I'm not going anywhere. The beginning of our time together today, I reviewed that an and statement was the overlap. An or statement is taking both and combining them together. Let's go ahead and solve a compound inequality expressed as an or statement. So x minus 2 is less than or equal to 5, or 1/2 x is greater than 6. First step is going to be to solve each of these individually and then come back around and figure out what the or means for the problem. So over here, x minus 2 is less than or equal to 5. We can add 2 to both sides. We get x is less than or equal to 7. Over here, 1/2 x is greater than 6. We can multiply both sides by 2. Multiplying by the reciprocal gets rid of the fraction. 2 over 1 is the reciprocal of 1/2. That just leaves us with x is greater than 12. The or statement is going to take our two individual lines. If we had 6 and we had 12, 7 and 12 on the number line, less than or equal to 7 would be that. Greater than 12 would be that. Or is a union. That's both of them together. And what would this be in interval notation then? Well, we would have parenthesis negative infinity with an endpoint of 7, square bracket. We're joining it with this other interval. So remember, we use the union symbol. And the other one is going to be a parenthesis 12 to infinity. And that's going to be how we solve an or inequality. Let's do another. 1/4 y less than -1, or 3 plus y greater than or equal to 5. Let's solve them both and then come back and deal with the fact that or is a union. To get rid of multiplying by 1/4, we would multiply both sides by the reciprocal, 4. So y is less than -1 times 4 is -4. Over here, subtract 3 from both sides. Y is greater than or equal to 2. -4, +2, less than -4, greater than +2. The or statement is both of them together, so they both make it on to the final answer. -infinity to -4 with a parenthesis, union, square bracket 2 to infinity. Let's go ahead and do an and statement now. Yay. So much fun. Math is fun and exciting, and the problems are oh so delighting. Let's take a look at -1/4 t less than 2. And this is going to be an intersection, and 0.52 t greater than or equal to 1.3. Decimals and fractions, seriously? Okay. It's okay, we can handle it. Getting rid of dividing by -1/4, we can multiply both sides by the reciprocal. That would be multiplying both sides by -4. Excuse me. And once we actually do multiply both sides by negative, that's going to switch it from a less than to a greater than. 2 times -4 is -8. We're just left with the t on the left. Over here, 0.52 t greater than 1.3. We'll go ahead and divide both sides by 0.52. If you get your calculator, I know you don't want to do it by hand. I don't want to do it by hand either. So we're not going to. 1.3 divided by 0.52 equals exactly 2.5. That's what the book said it would be. I didn't trust it. I should have trusted it. So we have t is greater than or equal to 2.5, and t is greater than -8. So if we had -8 positive 2.5 greater than or equal to 2.5 would be that. Greater than negative 8 would be this. The intersection is the overlap. The overlap happens here. So just greater than or equal to 2.5. Now, sometimes we can see inequalities joined together and written in this form. We saw things like this last time we were together. It can be in this form before we solve them as well. Let's say we had 5 is less than negative 2x plus 7 is less than or equal to 11. This actually represents an and statement of these two different inequalities. And if you don't see the two different inequalities right now, this might help. There's the second one. If I get rid of the entire left side, then the middle becomes the new left and the right stays the right. Negative 2x plus 7 less than or equal to 11. The other one's what happens when I get rid of the right. The middle becomes the new right. 5 is less than negative 2x plus 7. So this is an and statement that joins both of these. And so let's just play out the and then we'll come back and we'll play out the 3 part without changing anything. Seems like a good plan. If I subtract 7 from both sides, negative 2x is less than or equal to 4. Divide both sides by negative 2. X, switch this inequality greater than or equal to negative 2. Over here, subtract 7 from both sides. Negative 2 is less than negative 2x. Divide both sides by negative 2. Negative 2 divided by negative 2 is positive 1. Dividing by the negative means we switch the sign. And there's the x. This would be the same as x and 1. If we switch the sides, the x keeps the little point. Pac-Man's mouth opens towards the 1. So we have x is less than 1 and x is greater than or equal to negative 2. And statement is the overlap. So if we think of the number line, negative 2, positive 1, we would have less than 1. We would have greater than or equal to negative 2. And our answer would be the overlap. Our answer would be between negative 2 and 1 with a square bracket on the -2 and a parenthesis on the 1. That's the long way, splitting it up into 2, dealing with the and statement. There's a shortcut of sorts that's going to get us to the same answer. And it's just leaving it together. Instead of solving that one and then solving that one and using our strategy of whatever we do on one side, we do on the other, trying to get X on one side, let's get X in the middle. And whatever we do in the middle, we do on both of the other sides. So to get the X by itself, we got to get the -2X by itself. We got to get rid of +7. We do that with -7. Whatever we do in the middle, we have to do everywhere. All 3 sides, left, middle, right. That just leaves -2X in the middle. 11 minus 7 is 4. 5 minus 7 is -2. To get the X by itself, we have to get rid of multiplying by -2. So we divide by -2. Whatever we do in the middle, we do everywhere. Since we divided by -2, things switch. The less thans become greater thans. Less than or equal to becomes greater than or equal to. -2 divided by -2 is +1. 4 divided by -2 is -2. Now, before I do anything else, I want to take a look at what happened here. When things are written like this, a 3-part inequality, we use less thans. And because we use less than, because, for instance, 1 is less than 2 is less than 3, that works because the 1 is less than the 3. So it kind of has this transitive property. We want the least thing on the left, the greater thing on the right. -2 is less than 4. That's why we can use less than less than. 5 is less than 11. That's why we can use less than less than. But here, once we divide both sides by -2, there's a +1 on the left and a -2 on the right. Well, 1 is not less than -2. But guess what? The same time that that happened, the same time that became untrue, was the same time we divided everything by -2, which switches the inequality signs, which means everything's okay again. Because now, if we swap everything the way we do when we bring the signs with it, the -2 can come over here, the +1 can go over there, and the point stays with the -2. The big end stays with the X. Likewise over here, the big end goes with the 1. The point stays with the X. If you want to imagine, I took this answer, stuck a stake in it, and then spun it around. Everything flips. -2, point, big end, X, point, big end, 1. Everything flipped. It wasn't just changing the sign. Once we did that, it was greater than, and we don't write things like that. So we got to switch it. Got to stick a stake in it and flip it around. And look, now the or equal to is over here. The regular is over there. What would this be? It would be X between a -2 and a positive 1, with the or equal to being a square bracket on the left, the no or equal to being a parenthesis on the right. Same answer that we got. Maybe even easier because we didn't have to go through the number line to figure out how to write this as an interval. We can see our two endpoints. The smallest is -2, the largest is 1. Square bracket, no square bracket. Okay. Let's look at another. -16 is less than or equal to -3y minus 4 is less than 2. Whatever we do in the middle, we have to do to both sides. We want to get the y by itself, which means we need to get the -3y by itself. We need to get rid of the -4. We do that with +4. And we do it on all 3 parts. -16 plus 4 is -12. We just have our -3y in the middle. 2 plus 4 is 6. Next, divide all parts by -3. -12 divided by -3 is +4. Since we divided by -3, we got to switch the inequality signs. Y in the middle. 6 divided by -3 is -2 there. We no longer have the least thing on the left with less thans. We want to switch everything around so we can have that. So copying it this way, we have our -2 first. The point goes towards the -2, big N towards the Y. And then the less than or equal to points at the Y with the big end having a 4. If you want to see it on the graph, you can. Between -2 and 4, no or equal to, yes or equal to, and we shade in the middle. In other words, -2 to 4, parenthesis on the left, square bracket on the right. Let's complicate it up. What's the best way of complicating something? Fraction. Okay. 2 is greater than or equal to p minus 2 over -3 is greater than or equal to -1. So this is odd, maybe at first, that we see that it's a compound inequality, but it's not given with the least on the left and the greatest on the right. But guess what? The very first thing we're going to do is multiply all sides by -3. And that's going to fix it in the very next step. So nothing to worry about. In order to get the p by itself, we got to get the p minus 2 by itself. We got to undo dividing by -3. So we're going to multiply all sides by -3. So 2 times negative 3, this middle thing times negative 3, the negative 1 times negative 3. And since we're multiplying all things by negative 3, that's going to switch the inequalities around. And that should take care of our weirdness from the beginning. Negative 3 times 2 is negative 6. We just have the p minus 2 in the center. Negative 3 times negative 1 is positive 3. And yep, everything looks good now. If we add 2 everywhere, negative 6 plus 2 is negative 4, is less than or equal to p, is less than or equal to positive 5. So in square brackets, we have the endpoints negative 4 and positive 5. Not so bad. Let's go ahead and do one more. 8 is greater than t plus 4 over negative 2 is greater than negative 5. Same sort of deal. We want to get the t by itself, so we got to get the t plus 4 by itself. We've got to undo dividing by negative 2, and we're going to do that with multiplying by negative 2 everywhere. 8 times negative 2 is negative 16. Switch the sign. T plus 4 in the middle. Switch the sign. Negative 5 times negative 2 is positive 10. So why does that work? It's because we are multiplying everything by negative 2. Negative 2 times 8. Negative 2 times negative 5. Negative 2 times the middle cancels those out. Just leaves us with the t plus 4. Since we're multiplying by a negative number, that switches these signs. Now to get the t by itself, subtract 4 everywhere. That gives me negative 20 on the left, t in the middle, and 6 on the right. This would be parentheses around the endpoints negative 20 and 6.